to Arizona State University's Global Freshman Academy MAT 117 College Algebra and Problem Solving course. This video will cover the topic using a graphing calculator to find local extrema of a polynomial function. To find the local extrema of a polynomial using a graphing calculator, we first enter the equation into the calculator, graph it, and then use the calculator's built-in estimation tools to find approximate values of any extrema. Let's break it down. Suppose we were given the polynomial function h defined as h of x equals negative 4x to the fourth power minus 3x to the third power plus 7x squared minus x minus 5. And we want to find all local maxima.
What's a maxima?
The word maxima is the plural of maximum. A polynomial can have multiple x values where there's a local maximum. So we're going to look for all of them. The first step to using a graphing calculator to find a local maxima is to input the equation into the calculator. We do that by pressing y equals and entering the equation. Once you've double checked to make sure that you've entered the equation properly, you can view the graph of it by pressing the Graph tab. From here, we can use the zoom tool to make sure that we're seeing all the important features of the graph. In this case, it looks like from this zoom we can see all of our local maxima, which is what we're trying to find in this example. Once we're satisfied with our zoom, we can press OK to return to the main menu. Now it's time to calculate the local maxima. We click extrema here, and this brings us to a menu where we can find the value of any local maximum or local minimum. In this graph, we see that there are two local maxima. One right here and one right here.
What makes a point a local maximum?
Good question. A local maximum is any point on the graph where the line switches from increasing to decreasing. This happens once here, where our graph is increasing, and then at this point it starts decreasing. And again here, where it's increasing for just a little bit here, and then starts decreasing. Our first step is to move these blue lines so that they create an interval around one of our local maxima. Let's start with this one over here. We see that this local maxima is somewhere between 0 and 1. So let's change our left bound to 0. This is the lower number. And our right bound to 1, which it's already set at.
What happens if we have a wider interval?
When we use the maximum tool, the calculator is just going to tell us the highest value within our interval. So if our interval is too wide and it includes values on the graph that are higher than the actual local maximum we're looking for, we'll get the wrong answer. Now that our interval is set correctly, we can click the maximum button, and now our graph will show us the local maximum. This tells us that there is a local maximum at the point 0.64, comma, negative 4.23. To find our other local maximum, we can click New and do the same thing again, but this time we're going to choose an interval that surrounds this local maximum. We can change the interval either by changing these values here or by just dragging the blue lines to surround our local maximum. Now that our local maximum that we're seeking is the highest point within our interval, we can click Maximum, and now we found the value of our other local maximum. This tells us that there is another local maximum at the point negative 1.28, comma, 3.30. Since there are no other local maxima in our graph, our final answer is 0.64, comma, negative 4.23 and negative 1.28, comma, 3.30.
So to find the local extrema of a polynomial using a graphing calculator, we first enter the equation into the calculator, graph it, and then use the calculator's built-in tools to find the value of any extrema.
Right.